There are two types of equilibrium expression that we will encounter in this course. We have Kc, a concentration equilibrium expression, and Kp, one that involves partial pressures. If you consider a generalized expression with A plus B in equilibrium with C and D, we can write Kc and Kp expressions. In both cases, what you can do is remember to write products over reactants. We've written an expression now that has the product concentrations multiplied together, C times D, in square brackets representing molarity. And on the bottom of the expression we have A times B, again, in square brackets representing concentration. What we do next is finish the expression, and we do this by putting exponents on each of the terms. The exponents that go with each term correspond to their stoichiometric coefficients from the balanced equilibrium expression. The coefficient for the C term is C. The coefficient for the D term is D. A and B are similar. And the process is exactly the same for Kp. The only difference is that instead of concentrations, you use partial pressures. You can see that the general structure is the same for both Kc and Kp. Now we'll do an actual example. In this example, we have SO2 and oxygen in equilibrium with SO3. In this case, all three are gases, and we can represent gases with a concentration or with a partial pressure. So we could write easily a Kp or a Kc for this. The structures would be the same though, so we'll just write a Kc. Again, products go on the top, reactants go on the bottom, and we just fill in the exponents based on the stoichiometric coefficients. The SO3 has a coefficient of 2, so it gets an exponent of 2. The SO2 has an exponent of 2, it also gets that exponent. The coefficient for oxygen is 1, and we don't actually write in the 1, we just omit it, and it's understood that anything without an exponent is raised to the power of 1. Sometimes when you look at the reactants and products in a reaction, they don't all have the same state. You can have a mixture of solids and liquids and gases and aqueous components. And when you have a mixture of different states, you have a heterogeneous equilibrium. An important thing to note is that pure solids and liquids, so something that has a subscript S or a subscript L, does not go in a K expression. So pure solids and liquids do not go into K expressions. Instead, what you do is you write a 1 anytime you would have to put a solid or a liquid in. The reason behind this exclusion is related to something called the chemical activity. In this example, we can ignore the P4O10 because it's a solid. It should show up in our equilibrium expression as a 1.